In the unending silent darkness between the stars, our solar system drifts as a tranquil island of light. For billions of years it has followed a clockwork rhythm, a celestial dance of sublime and predictable elegance. Planets trace their ancient elliptical paths. Moons hold faithful vigil over their giant wards. The sun, our magnificent life-giving star, presides over it all with the serene authority of gravity and light. We have grown comfortable in this predictable cosmos. Our telescopes, ever more powerful, scan the heavens, cataloguing the familiar, charting the expected. We have mapped our neighborhood with exquisite precision. We believed we knew the cast of characters in our cosmic play, but then something new entered the stage, something that did not belong. It arrived unannounced, a whisper in the data streams, an anomaly flagged by an algorithm in the deep of night. At first it was dismissed as an error, a ghost in the machine. A digital smudge on a pristine image of the void, but the smudge appeared again in the next observation, and the next, and it was moving. It was moving with astonishing velocity on a trajectory so steep, so alien to the gentle curves of our system's orbits, that it could only have come from one place, the fathomless interstellar abyss. It wasn't a lone traveller like the enigmatic Oumuamua. It was not a single wandering comet from the cold frontiers. What ripped through the digital net cast by humanity was a formation, a swarm, a vast, sprawling field of debris, a procession of countless individual pieces stretching for millions of kilometers across the interplanetary vacuum. This mysterious cavalcade was on a direct plunging course, a kamikaze run toward the heart of our solar system. Its destination, a hairpin turn around our Sunday. The initial disbelief in control rooms across the globe quickly evaporated, replaced by a frenetic, unified urgency. Every major observatory on the planet, and in orbit above it, swiveled its colossal eye toward the approaching enigma. A single question echoed through the halls of science, a question that struck at the very core of our understanding of the universe and our place within it. What in the heavens are we looking at? Is this the shattered remnant of some cosmic cataclysm, the pulverized corpse of a world that met a violent end? Or is it something else, something that chills the soul with its implications? Are these objects coordinated? Is this cosmic wreckage or a fleet? The story of this discovery is not one of a single brilliant mind. It is a tale of the modern age of astronomy. For centuries, the search for new celestial bodies was a profoundly personal and patient endeavour. Imagine a lone astronomer in the 18th century Charles Messier night after night, sweeping the sky with his modest telescope. He was hunting for comets, the rock stars of his era, but he kept finding faint, fuzzy objects that stubbornly refused to move. Frustrated, he began to catalogue them as nuisances, a list of things, times, not times to look at. That catalogue, born of irritation, became one of the most famous in astronomy, a treasure map of distant galaxies and nebulae. His method, and the methods of those who followed for 200 years, was one of painstaking visual comparison, drawing star charts by hand, overlaying them night after night, searching for a single errant point of light that had shifted its position. This is how the first asteroids were found, tiny worlds like Ceres and Vesta, revealed by the slow, methodical dedication of individuals. Today, the hunt has transformed beyond recognition. The lone astronomer has been replaced by global networks of robotic eyes. Instruments like the Pan-STARRS telescope in Hawaii or the forthcoming Vera-C Rubin Observatory in Chile are not telescopes in the classical sense. They are colossal digital cameras attached to world-class optics designed to photograph the entire visible sky every few nights. They produce not a trickle of observations but a fire hose of data. Petabytes of information pour forth a digital deluge so vast that no team of humans could ever hope to sift through it. Instead, we deploy artificial intelligence, sophisticated algorithms. Our silent, tireless partners in discovery scan this torrent of cosmic information. They are programmed to recognize the known patterns of the universe, the steady light of stars, the predictable arcs of planets, the familiar fuzz of a distant galaxy. Their primary mission is to find the one thing that breaks the pattern, to flag the unexpected. And on a seemingly ordinary Tuesday it did. An alert pinged on a server was cross-referenced with other surveys and escalated to a human analyst. The signal was faint, but its implications were monumental. It wasn't a single object on a hyperbolic interstellar path. The algorithm had identified a multitude of them all clustered together, all sharing the same impossible trajectory. They were like a flock of birds migrating from a land we've never seen. Initial calculations were frantic, checked and rechecked. The velocity was staggering, far beyond the escape velocity of our Sunday. This swarm was not here to stay. It was a transient, a fleeting visitor from the interstellar dark. It would scream past the sun and then be flung back out into the void, never to return. We had one chance, a window of mere months to study this apparition. The scientific community, a global village connected by the internet, lit up with urgent correspondence. Telescope time, a fiercely guarded and precious commodity, was reallocated. Decades-long research projects were put on hold. From the sun-scorched plains of the Atacama Desert to the frozen peaks of Mauna Kea, the great observatories of Earth turned their gaze as one. The Hubble and James Webb Space Telescopes adjusted their schedules, aiming their legendary mirrors at the incoming mystery. Humanity was about to stare into the face of a true unknown. The first and most rational hypothesis was that we were witnessing the aftermath of a spectacular celestial demolition. The universe, for all its beauty, is a profoundly violent place. Worlds are not permanent fixtures, they can be destroyed, and we have seen it happen before right here in our own cosmic backyard. In 1993, astronomers Carolyn and Eugene Shoemaker and David Levy discovered a strange, distorted object near Jupiter. It wasn't a typical comet, it looked squashed, elongated. As they watched, they realized they were witnessing a cosmic marvel. The comet, now named Shoemaker-Levy 9, had passed too close to the colossal gravitational field of Jupiter. The immense tidal forces of the gas giant had acted upon the fragile, icy comet, like a cosmic gravitational rack pulling it apart. To understand this process, imagine an old wooden ship, a galleon from the age of sail, caught in a monstrous whirlpool. The whirlpool doesn't just pull the ship down. The differential forces of the swirling water are much stronger at the front of the ship than at the back. This tidal shear would rip the vessel asunder. The main mast would snap, the hull would splinter, the deck would be torn from its moorings. What was once a single cohesive ship becomes a long trailing line of wreckage, planks, barrels, tattered sails, all following the same doomed spiral. This is precisely what happened to Shoemaker-Levy 9. Jupiter's gravity tore it into more than 20 distinct fragments. These pieces, once a single cometary nucleus, were now strung out across the sky like a celestial string of pearls. For the next year, the world watched, transfixed, as this train of cosmic shrapnel continued its orbit, a death march that would lead it to a direct collision with Jupiter. The impacts, when they came in 1994, were spectacular. Each fragment exploded in Jupiter's atmosphere with a force that dwarfed the combined nuclear arsenal of Earth. Dark planet-sized scars marred the beautiful face of the gas giant for months. Shoemaker-Levy 9 provided a stunning textbook example of how a single object could become a debris field. So, as astronomers studied the incoming interstellar swarm, this was their working model. Perhaps this visitor was once a single large body. A rogue planet ejected from its home star system billions of years ago. Or maybe it was a giant comet from the Oort cloud of another star, and somewhere on its lonely, eons-long journey through the galaxy, it had a catastrophic encounter. Perhaps it passed too close to a wandering black hole whose tidal forces shredded it into a million pieces. Or maybe it collided with another interstellar wanderer in a hypervelocity impact that vaporized and pulverized both objects. The resulting cloud of shrapnel, bound by its shared momentum, would continue along its path, a ghostly funeral procession marking the grave of a long-dead world. This theory was plausible, elegant, and comfortably natural. It fit within our known physics. It required no paradigm shifts. The evidence we would expect to see for this cosmic wreckage hypothesis would be clear. First, a wide variety of shapes and sizes. A cataclysmic event doesn't produce uniform pieces. It produces a chaotic mix of boulders, dust, and everything in between. We would expect to see some large core fragments and a vast tail of smaller, more numerous bits. Second, the objects should be tumbling chaotically. Like the debris from an explosion, each piece would be sent spinning on its own unique axis, flashing and glinting in the sunlight in an irregular, unpredictable pattern. The light curve, the graph of its brightness over time, should be a jagged mess. Third, spectroscopy would be key. By analysing the light reflecting off the objects, we could determine their chemical composition. If this were the wreckage of a shattered planet or comet, we would expect to see a mixture of familiar materials: silicate rock, various ices like water and carbon monoxide, and perhaps some carbon-based organic compounds. It would look like a jumbled cosmic recycling yard. For weeks, this narrative held. The data seemed to conform. The field was vast and dispersed. Initial observations were difficult, but as the swarm drew closer and our more powerful instruments could resolve the individual components, a new picture began to emerge. A picture that was far, far stranger. The first crack in the cosmic wreckage theory was the uniformity of the objects. As the resolution of our images improved, we saw that while there was some variation, a significant number of the largest objects were remarkably similar in size. This was not the expected power law distribution of a shattered body. An explosion creates a few big pieces and a cascade of smaller ones. This looked less like the debris from a blast and more like a box of marbles that had been spilled. Then came the analysis of their motion. They were not tumbling chaotically. While they did rotate, their rotations seemed strangely stable. Their light curves were not the jagged, unpredictable patterns of shattered rock. They were periodic, almost rhythmic. Some even showed a peculiar polarization, a quality of light that suggested they were reflecting sunlight from a smooth, perhaps even metallic surface. But the most unsettling discovery was their formation. It was not a random expanding cloud. The objects maintained a persistent, if loose, structure. They were spread out over a vast area, yet their relative positions seemed to be governed by something more than just their initial momentum. They were drifting apart as expected, but far more slowly than any model of a cataclysmic breakup could explain. It was as if they were communicating, maintaining a delicate gravitational or perhaps non-gravitational dance across millions of miles. This is where the whispers began in the scientific community. The hushed late-night conversations. The emails sent with subject lines like, "Are you seeing this?" The unsettling feeling that we were looking at something that defied a simple, natural explanation. To appreciate the gravity of this shift in thinking, we must look back to another anomalous visitor, Oumuamua. In 2017, this object, the first confirmed interstellar visitor, streaked through our solar system. It was bizarre from the very beginning. Its trajectory was hyperbolic, its speed immense. But its most peculiar characteristic was its shape. Based on its extreme variations in brightness, astronomers deduced it must be extraordinarily elongated, perhaps 10 times as long as it was wide, like a cosmic cigar or needle. No asteroid or comet ever seen had such a radical shape. Then as it passed the sun and began to depart, it did something utterly baffling. It accelerated. It pushed away from the sun with a tiny but measurable force that could not be explained by gravity alone. The initial explanation was cometary outgassing. As a comet nears the sun, its ices sublimate into gas, creating jets that act like tiny rocket thrusters. But astronomers looked for a cometary tail, a coma of gas and dust, and found nothing, absolutely nothing. This led Harvard astronomer Avi Loeb to propose a radical and deeply controversial hypothesis. What if Oumuamua was not a natural object at all? What if its strange shape and its mysterious acceleration were signs of technology? He suggested it could be a solar sail, a thin, light craft pushed by the pressure of starlight itself. Or perhaps it was a defunct probe, an alien artifact tumbling through the cosmos for millions of years. The scientific establishment largely rejected this idea, favoring more exotic but still natural explanations. But the seed of doubt had been planted. Now, with this new debris field, that seed began to sprout. Oumuamua was a single perplexing data point. It was an outlier, a statistical fluke you could, if you chose, explain away. But this new phenomenon was not a single object. It was a multitude. Imagine walking through a vast, empty desert. You find a single, perfectly spherical rock. It's unusual, certainly. You might wonder at the geological processes, the erosion by wind and sand, that could create such a perfect shape. It's a curiosity, a mystery of nature. Now imagine you walk over the next dune and find 10,000 of these perfectly spherical rocks, all of identical size laid out in a precise grid pattern. At that point, the natural explanation becomes absurd. The evidence for intelligent design becomes overwhelming. The debris field was presenting humanity with a similar leap in logic. The strange uniformity, the stable rotation, the non-random spacing, these were the grid of perfect spheres in the desert. The hypothesis that had once been on the extreme fringes of speculation now had to be brought to the center of the table. We had to seriously consider the possibility that these objects were artificial. If they were manufactured, what could they possibly be? The speculation ignited a firestorm of creativity and debate. One idea was that they are a fleet of probes. Perhaps Bracewell probes a concept proposed by scientist Ronald Bracewell. These are autonomous robotic explorers sent to star systems to listen for signs of intelligent life and, if found, to establish contact on behalf of their long-dead creators. Could this be such a fleet arriving in our system after a journey of millennia? Another more exotic idea is that they are von Neumann probes. Named after the brilliant mathematician John von Neumann, these are self-replicating spacecraft. They would arrive in a star system, use local resources like asteroids to build perfect copies of themselves, and then launch those copies toward new stars. In this way, a single probe could explore the entire galaxy over millions of years. Perhaps what we were seeing was one such fleet, its mission ancient and its origin unknowable, or perhaps the explanation was more dramatic. Could this be the wreckage of a great interstellar conflict? The remnants of a battle fought in the deep past, the debris now drifting through the cosmos like a celestial graveyard. Were these the shattered hulls of warships, their power sources dead, their crews long gone to dust? The most tantalizing possibility was that they were solar sails. Like Oumuamua, but on a grand scale. Perhaps they were a fleet of craft that had traveled between the stars, powered by the light of their home sun. Now, arriving in our system, they were unfurling their vast gossamer-thin sails to use our own sun's radiation as a brake, slowing down to take up orbit. This would explain the non-gravitational forces at play and the strange uniform reflection of light. Each of these possibilities was more mind-bending than the last. Each one forced us to confront the profound solitude we have always felt in the universe. As the swarm drew ever closer to the sun, the tension was palpable. The moment of perihelion, its closest approach, would be the ultimate test. The sun's ferocious heat and gravity would be the crucible in which the true nature of these objects would be revealed. The encounter was a moment of supreme scientific focus. Every instrument humanity could muster was pointed at this single patch of sky. The Parker Solar Probe and the Solar Orbiter, our sentinels at the sun, were in prime position, their instruments braced for the flyby. The James Webb Space Telescope, shielded from the sun's glare, prepared to perform the most detailed spectroscopic analysis in history. Radio telescopes from the Very Large Array in New Mexico to FAST in China listened intently for any whisper of a transmission, any signal, however faint, that would betray a technological origin. As the leading edge of the swarm crossed the orbit of Mercury, the show began. Visually, it was a spectacle beyond imagination. Against the swirling, incandescent backdrop of the sun's corona, the objects became stark silhouettes. They began to glow, heated to thousands of degrees. If they were cometary, great plumes of gas and dust should have erupted from their surfaces, creating a magnificent collective tail. But there was nothing, no outgassing, no cometary activity. They withstood the inferno with an impossible resilience. The spectral analysis data began to stream back to Earth, and it was baffling. The reflected light showed the absorption lines of heavy metals, titanium, tungsten, and elements in isotopic ratios not found anywhere in our solar system. These were materials engineered for extreme durability. They were not the common rock and ice of a typical asteroid. They were manufactured alloys designed to endure the rigors of interstellar travel and the fury of a star. Then came the most shocking revelation of all. As the objects whipped around the sun, their trajectories were tracked with laser-like precision. They were not just following a passive gravitational curve. Several of the largest objects made minute, almost imperceptible course corrections. They were using the sun's gravity in a sophisticated slingshot maneuver, but they were also making tiny adjustments. It was the unmistakable signature of active guidance. They were not tumbling, they were steering. The control rooms on Earth were scenes of stunned silence. The data was undeniable. The natural cosmic wreckage theory was dead. The evidence pointed to one staggering, earth-shattering conclusion: these objects were technological artifacts, and they were under control. Now they are on their way out. Their velocity increased by the gravitational assist from the sun. They are heading back into the interstellar night, bound for some new, unknown destination in the cosmic ocean. They are already growing fainter. Soon they will be beyond the reach of our most powerful telescopes, disappearing back into the darkness from which they came. They leave behind a human race that is forever changed. We are left with a universe that is suddenly and irrevocably more complex, more mysterious, and more populated than we ever dreamed. The silence we thought we heard in the cosmos was not emptiness, it was simply our own deafness. We now stand at a profound fork in the road of our future. The Fermi paradox, the great question of where is everybody, has been answered. They are not absent, they are merely quiet, and they are passing through. This discovery will ignite a new golden age of exploration. The funding for space-based research will skyrocket. New, more ambitious missions will be planned. Perhaps a high-velocity probe, a desperate shot in the dark, will be launched in the coming decades to chase down the departing swarm, a multi-generational mission to catch a ghost. The search for extraterrestrial intelligence will transform from a fringe scientific endeavor into the most urgent quest of our time. We will no longer be listening for random radio signals. We will be actively scanning for the physical evidence of technology, for the heat signatures of starships, for the spectral lines of alien industry. But the deepest impact will be philosophical. For our entire history, we have defined ourselves by our uniqueness. We have been the sole actors on the cosmic stage. Now the curtain has been pulled back and we see that the stage is vast and has been occupied by others for an unimaginable length of time. What does this mean for our religions, our cultures, our sense of self? Are we a curiosity to these ancient travelers? An ant farm they observe as they speed along their cosmic highway? Did they even notice us? Or perhaps the most humbling thought of all, what if this wasn't a fleet of active probes? What if it truly was wreckage, just not natural wreckage? The ruins of a ship or a fleet of ships whose automated systems continue to follow their final programmed orders, executing a perfect gravitational turn, unaware that their creators have been gone for 1 billion years. A ghost ship sailing an empty ocean. We do not know. We may never know. The objects are departing, taking their secrets with them. They have left us with more questions than answers. They have held up a mirror to humanity, and in it we see our own reflection, a young, curious, and suddenly very small civilization. We are left looking up at the night sky, but it is no longer the same sky. It is now a place of infinite possibility, of breathtaking wonders, and of profound unanswered mysteries. The predictable clockwork solar system of our youth is gone. In its place is a universe teeming with unknown traffic, ancient voyagers, and the silent, enduring evidence that we are and have always been part of something much, much larger, and we are most certainly not alone.